Hello, dear students. So let's start our lecture and welcome to our next lecture of Matrices chapter class 12, Maths chapter 3. Till now, we have seen the matrix multiplication and what is like method of matrix multiplication, how it is multiplied. This was our last topic and this was very important. If you have missed the lecture, you can see the previous lecture on the official YouTube channel of GoAskNow Academy. So let's start this lecture and let's see what is the next example. So in the above example, we have already covered this that AB is not equal to BA. If the matrix multiplication is like AB, then it is not commutative, like AB is not equal to BA. And we have already seen the example of two matrices where A is 2, 3, 4, 5, 2, 1, and B is 1 minus 2, 3 minus 4, 2, 5. See here in the figure is of this page. You can observe here that these are two matrices and they have having different orders also. First matrix is of order 3 cross 2 and second matrix is of order 2 cross 3. So their product is not commutative. And if we assume that like we think that if two matrices are of same order, then their matrix multiplication be commutative. But it is also not true. If you have two matrices which are square, then it is not needful that both the matrices are their multiplication is what commutative also. So we will see one example for that also. Let's see here. So if you have a matrix as 1 0 0 minus 1 and B as 0 1 1 0, then AB can be found out by multiplying horizontal this row to this column. Okay, so you will get what 1 into 0 0 and 0 into 1 0. So this is 0. Similarly, you can find out this element. So 1 into 1 is 1 and 0 into 0 is 0. So 1 will come here. Similarly, here you will get minus 1 and here 0. Okay, so AB is coming out to be 0 1 minus 1 and 0. But if you do the VA calculation here, like if you find out the VA here, you will get as 0 minus 1 0 and 0. Just do the multiplication, you will find out that this is the BA matrix. So you can see here that AB is not equal to BAY because AB was coming equal to 0 1 minus 1 and 0, and BA is coming out to be 0 minus 1 1 and 0. So these are like different only. You can also like observe this carefully that they are different here. Okay, now we will see the next example and move forward in our discussion. Yes. So yeah, it is not commutative, it is written here. So it is possible that you have a square matrix and their like multiplication can be equal also, like commutative also, like AB can be equal to BA, but you have to choose some type of matrices like that only. So that is like true for some very rare matrices. Okay. So multiplication of diagonal matrices of same order will be commutative. So you must remember this point that your multiplication of diagonal matrices of same order will be commutative. Why it is so? Because if you take any matrix like A is equal to 1, 2, 0, 0 and B as 3, 0, 0, 4. So if you multiply here and find out AB, then it will come what? It will come like here as 3, okay, 0, 0, 4. And if you find out this is AB only. If you find out here B, A, then you will get what? 1, 0, 0, 2, 3, 0, 0, 4. Okay. So if the matrices are like diagonal, then you can see or observe that your like non-diagonal elements will not contribute here, and you will get the product as commutative. AB is equal to B is okay. That is why we will get here. So yes, zero matrix has the product of two non-zero matrices. We know that for real numbers AB, if AB is equal to 0, then either A is equal to 0 or B is equal to 0. So this you already know that this is the basic of like multiplication of two numbers. That if AB is equal to 0, then either A is equal to 0 or B is equal to 0. This need not be true for matrices. We will observe this through an example. So this case is not uh, true for matrices. Okay. So we will see that why it is not true. Find AB if A is equal to 0, 1, minus 1, 0, 2, and B is equal to 3, 5, 0, 0. We have AB is equal to what? If you find out here AB, then what is that? See here. For the first, first row and first column, you will get the first element as 0 into 3 plus minus 1 into 0. Okay. For second one, you will get 0 into 5 plus minus 1 into 0. Here you will get 0 into 3 plus 2 into 0. And here 0 into 5 plus minus 1. Minus 1 into 5 plus. Okay. Just a second. Yes, yes. 0, sorry. 0 into 5 plus 2 into 0. Okay, so what you are getting here? You are getting a 0, 0, 0, and 0. So this is a what? Null matrix. Okay. So it is shown here that if the product of two matrices is a zero matrix, it is not necessarily that necessary that one of the matrices is a zero matrix. So here you can see that A and B matrices are not zero matrices, but you are getting AB as zero matrix. Okay, this is your zero matrix only. So you can observe here that AB is not equal to means AB is zero, but A and B are not zero matrices. Okay, properties of multiplication of matrices. Now we will see some properties of matrix multiplication. Let's move forward and see what are these. So the multiplication of matrices possesses the following properties which we state here. The associative law for any three matrices A, B, and C, we have A, B in bracket into C is equal to A into bracket B into C whenever both sides of equality are defined. Okay. So if you have two matrices, like three matrices, okay, A, B, and C. Just a second. If you take some examples of A and B and C, here you can see in the example 16 here that they have taken A matrix, B matrix, and C matrix and find out the A into BC, then AB into C, and you can show here that AB into C is equal to A into B into C. Okay. So I leave it for you that how these multiplications are like associative. You can find out the proof of this. You don't need to remember the proof of these, but you should know that these are properties followed by matrix multiplication. The second property is the distributive law. For three matrices A, B, and C, A into B plus C is equal to AB into AB plus B AC. Okay, so plus will be addition will be distributed here. Similarly, A plus B into C is equal to AC plus BC whenever both sides of equality are defined. So if the both sides are defined equality here, so that will be like true. The existence of multiplication identity. For every square matrix A, there exists an identity matrix of same order such that IA is equal to AI is equal to A. Okay. So this is also true because if you have I identity matrix like this, just a second. Like I matrix is like for 2 cross 2, you have 1 1 0 0. Okay, so this is the identity matrix for what? So 2 cross 2 matrix. So this is a multiplicative identity also. If you multiply it, you will get what? IA is equal to A and AI is equal to A only. Okay. So I hope that you got the points that how these matrices are formed and what are the properties of these matrix multiplication. Now we will see some examples here and try to solve them. Okay. So here are the proof of these properties, the three properties we have seen. Okay. So you can just go through it and see that why it is so that these properties are followed here. Just take three matrices and multiply them. Find out the AB into C and A into BC. Okay. You will see that A into BC is equal to AB into C. If A is equal to this, B is equal to this, C is equal to this, find AC, BC and A plus BC. Also verify that A plus B into C is equal to AC plus BC. So you have to do what here? You have to just find out the value of A plus B, then A plus B into C, and then A plus B, AC and BC also here. Okay. And AC plus BC you do, then you have to find A plus, you have to prove that A plus B into C is equal to AC plus BC. Okay. So just find out these all quantities here. You will see that the distributive law is also following here. Okay. That is true also. Now, I hope that you can find out these things. So I will move to the next question and we will solve this. If A is equal to 1, 2, 3, 3 minus 2, 1, 1, 4, 2, 1, show that A cube minus 23A minus 40I equal to 0. How to do this question? Just find out the value of AQ here first. Okay. What you will do? Just multiply A to A, you will get A square. So here they have done the multiplication. Just to do A into A, so it will be multiplied to this and added. We will get 19 here. Then it will be multiplied to this and added here. We will get 4. Then this one is multiplied here and you will get 8 here. Similarly, this one we multiply to this, then you will get 1, 12, 8. And 4, 2, 1, you will get 14, 6, 15. Okay. So I hope that you can do the calculation part because it will take some more time. So I hope that you can find out the value of A square here. Okay. Now, what you will do that you can find out here A cube also. Just multiply A square you have found out in the previous step to A. You just multiply A to that. You will get what? A cube matrix also. So A cube matrix is coming out to be equal to 63, 46, 69 and 69 minus 6, 23, 92, 46, 63. Okay. Just do the calculation and you will find out this. So I hope that you can like do the calculation part and I assume that you are good in these calculations. Okay. So now you will find out AQ minus 23 and minus 40I. So AQ we have already found in the previous step. We will write that matrix here. Then minus 23 times A will be written like that. Minus 40I should be written like here only. Okay. Now just do the calculation. You will get as 63 minus 23 minus 40 as the first element. Okay. Here you can see that this is the first element. Then 46 minus 46 plus 0 is the second here. Then 69 minus 69 plus 0 is here. Similarly, here you can see that 69 minus 69 plus 0 is here. Okay. And here also minus 6 plus 46 minus 40. Then here also. So you can all find out these values. And I assume that you can do the calculation part. Just write it like that. You will get 0, 0, 0, 0, 0, 0, 0. That is null matrix. Okay. So this is proof after that you will get here null matrix only. That we have to prove in this question. Okay, so I hope that you got this question. I I left the calculation part here because that will make the calculation very lengthy, and I hope that you can do the multiplication. I already told you in the previous chapter also, previous lecture also, that how the multiplication of two matrices are done. They are multiplied horizontal to vertical arrangement. Okay, you can see the lecture in the previous one and follow the steps. Okay. Now we will move forward and see the next question. In a legislative assembly election, a political group hired a public relations firm to promote its candidate in three ways. So, in a legislative assembly election, there was a election going on. Okay, a politician group was there. They hired a public relations firm to promote its candidate in three ways: telephone, house calls, and letters. So these are three ways. The cost per contact in paise is given in matrix A. So cost per contact is given by matrix A, and these are numbers for these in paise. Okay. For telephone, you will have to pay 40 paise. Then for house call, you have to pay 100 paise, and for letter it is 50 paise. The number of contacts of each type made in two cities X and Y is given by. So there are two cities also here. So you can write them like X and Y in the row. Okay. And their telephone, house call, and letter in the column factor. Okay. So B is written like 1,000, 500, 5,000, and 3,000, 1,000, and 10,000. Find the total amount spent by the group in two cities X and Y. So we have to find out the total amount spent by group in the two cities. Just do the summation part here, you will get the result. So they have done similarly here also. Okay. Yeah, summation after like multiplying B to A, you will get the result by summation here. So these are the result. Just multiply that B matrix to A1. Okay, A matrix. So you will get the result. After multiplying it, you will get 40,000 plus 50,000 plus 250,000 as X, and 120,000 plus 100,000 plus 500,000 as Y. So the values are coming out to be equal to 340,000 and 720,000. So the total amount spent by that group in the two cities is 340,000 paise and 72,000 paise. That is rupees 3,400 and rupees 7,200 respectively. So these are the like amount spent here. Okay, because you are getting it in paise only. So rupees in rupees, these are the values of this. Okay. So we will move forward to the next exercise and see what are the questions in this exercise also. We will take only the good questions or the questions which are like needed to be solved. Okay. So the first question is, if A, let A is equal to 2432, B is equal to 13 minus 25, and C is equal to minus 65, 34, find each of the following. You have to find out the value of A plus B, then A minus B, then 3A minus C, AB, and BA. So this is very simple question, and I assume that you can find out these values because these are very simple here. Okay. Just find out the A plus B matrix, then A minus B, then 3A minus C, AB, and BA only. You can get the result. I will solve one part, that is third part, and you can do the rest part by yourself. Okay. Just find out. So 3 minus C, just do 3A. A is what? 2, 4, 3, 2. Minus C. C is what? Minus 2. Okay. 5, 3, 4. Just to do the calculation here, multiply it by 3, 6, 12, 9, 6. Minus of minus 2, 5. 3, 4. Okay. Now just do the calculation further. You will get 8. 12 minus 5 is 7. The 9 minus 3 is 6. 6 minus 4 is 2. So this is your life matrix for third part. Okay. So rest part you can do by yourself. And yeah, let's move further. Second question is compute the following. So you have to do the like addition of matrices here only. For first, second, third, fourth, you have to just do the addition here. So I will do the fourth part for you, and you can do the rest of the like parts. These are very simple questions. For fourth part, you will get what? Cos square x plus sin square x. In the first element, you will get cos square x plus sin square x. For second, you will get sin square x plus cos square x. For third part, you will get element f sin square x plus cos square x. Each element you are getting the same value. And the fourth one is cos square x plus sin square x. So you know the identity that cos square x plus sin square x is 1. So each element is coming out to be equal to 1, 1, 1. Okay. So that is the final answer of this. So I hope that you can do the rest part of this, because this is very simple questions in this exercise. Now the third question is asking that compute the indicated products. You have to find the like a matrix multiplication here. So I will do for you like fifth part, and rest you can do by yourself. So yeah, let's do this. For fifth one, you will get 2 1 is multiplied by here. So 2 into 1 plus 1 into minus 1. Then your 2 1 is multiplied to this. 2 into 0 plus 1 into 2. Okay. Then which is multiplied to this 2 into 1 plus 1 into 1. Then this is multiplied to this 3 into 1 plus 2 into minus 1. Similarly, this one 3 into 0 plus 2 into 2. And this 3 into 1 plus 1, 2 into 1. Okay. Minus 1 into 1 plus 1 into minus 1. Minus 1 into 0 plus 2 into 1. Minus 1 into 1 plus 1 into 1. Okay. So these are the terms you are getting here, or elements. After just doing the addition here, you will get it as 1, then 2, then here you will get 3, 1, 4, 5, minus 2, 2, 0. So this is the final answer of your fifth part. Okay. This is product of your matrices here. So I hope that you got this question, that how it is solved, and you can do all the parts like this only. Okay. Let's move further and see the next question. Fourth question says that if A is equal to this and B is equal to this matrix and C is equal to this, then compute A plus B and B minus C. Also verified that A plus B minus C is equal to A plus B minus C. So this question is also a very easy one. and you can find out here a plus b also and b minus c also. Then just substitute the values of a plus b minus c and a plus b minus of c. So I hope that you can do this by yourself, because you have to do just addition and subtraction here. Okay. Now fifth question is like, if a is equal to this 2 by 3, 1 by 5 by 3, 1 by 3, 2 by 3, 4 by 3. Okay. And these are the elements of this. Okay. So you have to find out what. So this exercise has 22 questions. So we will do some calculation in faster way, or we will leave some questions which are easier and move forward in a faster way. Okay. So your fifth question is compute 3a minus b minus 5b. I assume that you can do this, but this is also very simple. Just you have to find 3a and 5b matrices. Sixth question says simplify cos theta into cos theta sin theta minus sin theta cos theta plus sin theta into sin theta minus cos theta cos theta. I will do this because this is product like scalar product of matrix. I will take one example of this because we have not seen the question like this only. So just multiply cos theta to the whole elements here. You will get what? Cos square theta, cos theta, sin theta. Here you will get minus of cos theta sin theta, and here cos square theta only. Plus in the second one you will get sin square theta minus of sin theta cos theta, and here cos square theta cos theta sin theta, and here you will get sin square theta only. Just do the addition of both the matrices element. You will get what? Here the first one is cos square theta plus sin square theta. Then you will get 0 here, because these will these are equal and negative of each other. So here 0 will be there. Similarly for this you will get 2 cos theta. Okay. No, here minus sign is there, so you will get here 0 only. Just a second. See here, this was your yeah. This was your minus cos theta sin theta. Okay. And this is cos theta sin theta, you will get here 0 only. And this one is sin square theta plus cos square theta. So these diagonal elements are 1 only, because you are getting cos square theta plus sin square theta. This is 1. This is also 1. This is 0, 0. You are getting identity matrix of order 2 cross 2. Okay. So I hope that you got this question. Let's move to the next one. So in the seventh one, we have to find out x and y, if x plus y is this and x1 is y is this. Okay. So just add them. Matrices are added here. We have done such an example in the previous lecture, but how you can find out the values of x and y if x plus y is given and x minus y. Just add them first. Firstly, add the x plus y and x minus y, then subtract them. You will get the values of x and y. I hope that you can do these questions, and these are easy one. So we will skip these questions, and this will be like done by you only in the homework section. Okay. Yes. So question 8 is there. It says that find x if y is equal to 3, 2, 1, 4, and 2x plus y is equal to 1, 0, minus 3 and 2. How to this question? Just substitute the value of y here and you will find out the value of x. So I will do this for you. Like 2x can be written like 1, 0, minus 3, 2, minus of y matrix, because y will go here and it will be minus y. So write down the value of y here. You will get as 3, 2, 1, 4. Okay. Now divide the whole. After taking the difference, you will divide it by whole by 2, and you will get the value of x. So this is also a very simple example exercise question. 1 minus 3 is minus 2. 0 minus 2 is minus 2. Minus 3 minus 1 is your minus 4. And 2 minus 4 is minus 2 only. Okay. Yes. So just now divided by 1 by 2. 1 by 2. Okay. You will get what? Minus 1, minus 1, minus 2, minus 1. This is your final answer for x. This is your x. I hope you got this question. This was also very simple one. Let's move further and see the next question. So the ninth question is, find x and y if 2 into 1 in 3 0 x plus y 0 1 2 is equal to 5 6 1 8. Okay, so here we have to find the values of x and y. So how to do this question? Just find out the left hand side by addition and compare the left hand side elements to corresponding right hand side element. Okay, because the order of both the left hand side and right hand side matrices are equal. So you just need to compare the corresponding elements of both the matrices of left hand side and right hand side. You can find out the x and y values. So I hope that you can do this question. Okay, these are simple one. So we will move forward. Solve the equation for x, y, z and t if 2x, z. So this is also similar to the first previous one, but here you have like two variables and here you have four variables. So you will get linear equation in two variables, both for two pairs. Okay, you can easily solve this if you know the linear equation in two variables concept. So you can easily solve this also. Now 11th question is x y into 2 by 3 plus y into minus 1 by 1 is equal to 10 by 5. This is also similar to the first ninth question, because here you have to compare the left hand side matrix to right hand side matrix elements. Okay, that is also very easy one. Your 12th question is given 3 x y z w is equal to x 6 minus 1 2 w plus 4 x plus y z plus w and 3. Find the values of x, y, z and w. Okay. So this one question is similar to the previous two examples. Here you are like given x, y, z and w, four variables, and you have to find out the value of each variable. So just to do the calculation, you will get the linear equation of two variables for both pairs, and you will find out the value of x, y, z and w. Okay. Just a second. Yes. So, sorry for the interruption. We will continue next question. Question 13 says that if fx is equal to cos x minus sin x 0, sin x cos x 0, 0, 0, 1, show that fx into fy is equal to fx plus y. Okay. So I will do this question for you, and this is also simple one. You can verify this question if you do the calculation part. Just find out fx into fy. So fx is what? Cos x minus sin x 0, sin x cos x 0, 0, 0, 1. And you have to multiply it with fy. Fy will be what? Cos of y, because x is replaced by y here. So cos y will be there, minus sin y 0, 0, 1, 0, 0, sin y, cos y. Now you have to multiply these both matrices and find out and verify that it is equal to fx plus y. So just multiply it, you will get what? Cos x into cos y, okay, minus of sin x sin y. This is your first element. Similarly, for the second one, you will get minus of cos x sin y and minus of cos x, cos y and sin x. So this is your second element. Okay. And for third one, you will get what? 0 only. So I will write it in next line. Okay. Just a second. Okay. I should write it in more space, please. Yes. So write it here only. So there will be more space. So what will be this? Cos x, cos y, minus of sin x, sin y. Okay. And this one is minus of cos x, sin y, minus of sin x. Okay. Yeah, yeah. Sin x, cos y. And this one is 0. Similarly, you can find out the here element. It will be sin x, cos y, and plus cos x, sin y. For this, you will get minus of sin x, sin y, and here plus cos x, cos y. Then here 0 only. So these are the like elements for the second row. Okay. And the third row, what you will get? 0, 0, 1 is there. So you will get 0 here. And here you will get 0. And here you will get 1. So this is your fx into fy. Okay. Now just find out the value of cos x minus cos x. So this is your what? Compound angle formula. If you remember of 11th class. Okay. So you can write it like what? Cos A cos B minus sin A sin B. What is the formula for that? Cos x plus y only. Okay. And for minus cos x sin y minus sin x sin y, you will get minus of sin x plus y. Okay. And it is 0. Here you will get sine of x plus y for your compound angle formula. Here also you will get what? Cos of x plus y. And here you will get 0. Then here 1, 0, 0. You can observe here that this is not none other than what? Fx plus y. Just replace x plus y here. In this expression, you will get this only. So it is proved that left hand side is equal to right hand side here. I hope that you got this question also. This was a good one, but it was easier, but it was lengthy, like little bit lengthy because calculation is lengthy here. So I assume that you like the all the like questions today we have done, and this exercise is little bit lengthy, so it will be not covered in this lecture. And yeah, due to some kind time constraints, we will like continue our lecture in the next class. And till now, if you have any doubt or suggestion of this lecture, you can ask in the chat box or comment there. And if you also want any private session or one-to-one session from us, you can also tell us. Okay. So yeah, thank you and goodbye today. Okay.